All right, we are going to start tiptoeing into proofs in geometry. This is probably the frustrating part of geometry that you're going to have to get the hang of. Basically, what you're going to be doing is solving mathematical equations, but for each step of the solving process, you're going to tell me what is the reason you did that step. In other words, prove why you got that answer you did. I'm going to walk you through this at first, guys. You're going to prove it by doing these, showing these different properties. And so we start off with algebra because it's a little easier. You've seen all these properties before. I know we did them in Algebra 1 last year. You have the addition property, subtraction, multiplication, division, and substitution. So when you're solving your problem, think about these as answers to why you do what you do. So let's look at example 1 and go through one. You have 2x plus 5 equals 20 minus 3x. So for each step of this, you have to write the reason. I should have given myself more space here. I'm going to do it. New page. Write a little smaller. 2x plus 5 equals 20 minus 3x. Okay, now this one's easy. Whenever you rewrite the problem on your paper, all you got to say is that this is the given, meaning they gave you this equation. What would be the first thing we're going to do to solve for x here? Let's move that 3x. So we're going to add 3x here and add 3x here. This is called what? Look at those properties. What did we do? Yep, we did the addition property of equality. I'm okay if you want to abbreviate things. I'll know what you're talking about. Addition property of equality. After we move that over here, this cancels, and I have to add these, and I get 5x plus 5 equals 20. All I'm doing here is simplifying because I combined that 3 and 2. Good so far? Now, how do I move that 5? Yep, so I'm going to subtract from both sides. Which property of equality do you think that one is? Yep. Subtract property of equality. And then my last step is to do what? Divide. So this is the division property. Sometimes it wants you to write simplify other. I think the only time you have to do the simplification is when you're combining the variables. So on this first step here. So that's why when we got to here we did that. Make sense? So you're literally just doing each step and then telling me what property you did to make that step work. So let's look at the next example. Now, you've all seen distributive property, right? You have that written in your book. So this example 2 is going to use distributive property. So we have negative 4, open parentheses, 11x minus, plus 2 equals 80. What's my first step here? What's the first reason, I'm sorry? So you're going to write given. Then we're going to do what? So I get negative 44x minus 8. And this is distribute. Property. Good. What would be your next step? Add the 8. So I get negative 44x equals 80. And what property did we use here? Yep. So we used the addition property of equality. And then my last step was which gives you what? Division property of equality gives you the last step. Any questions? Okay. Oh, did I need to go back? I might have moved too soon. Good. All right, so now let's look at one with a word problem. So we're talking about heart rate. This is example 3 in your books. When you exercise, your target heart rate should be between 50 to 70% of your maximum heart rate. Your target heart rate, R, at 70% can be determined by the formula R equals 0.70, 220 minus A, where A represents your age in years. They would like you to solve the formula for A. So I wrote down the formula. What is this called? For my reason. The given. What's my first step? Yep, so we're going to distribute that and that. So I have R equals 0.70 times 220 is 154. And then minus 0.70 times A. What property did I do? Yep. Good. Now what's my next step? Remember, we're trying to get A by itself. So I would move the 154. Very good. So I get R minus 154 equals negative 0.70A. And what did I do? Subtraction property of equality. Good. Okay, my last step is to do what? Yep, divide by negative 0.70. So my answer, I get R minus 154 divided by negative 0.70 equals A. And what was this property? Division. Very good. All right. You have tiptoed into what we call proofs. You're proving why you do each step. All right, let's look at some more problems here. Okay, you need to make sure these are in your journal. You have the reflexive property, the symmetric property, and the transitive property. You have used these, you just may not have known or remembered what they were called. Reflexive is, think of that as saying it's true because it's itself. Like if you said 12 equals 12. Well, 12 equals 12 because it's reflexive. It's itself. Symmetric property is you can flip the equation. So if I have A equals B, I can flip it over and say B equals A. That's symmetric. And transitive is when you have three sets. If I say A equals B and B equals C, then you have the B on both. I can cut the B's out and say A equals C. Make sense? Good. So these are some of the rules now. They're opening it up to any rules now that you can use for your explanations. All right, we're going to use this for our example. So you are designing a logo to sell daffodils. Use the information given to determine whether the measure of angle EBA equals the measure of angle DBC. Okay? Look at this picture right here. What in here is information that they straight up told us? Try not to look at the solution so you guys get used to figuring this out. You see the two little red lines? So what does that tell us? That they're the exact same angle. So we can say the measure of angle 1 is equal to the measure of angle 3. Right? Because of the picture. And we say the reason is given. Because it's straight off the information they gave us. Okay, now we're trying to get to, let's see here. I want to see if EBA equals DBC. So that's what we're trying to get to while we do all this. So in order to do that, we need to prove that the angles equal each other. What can I say about, if I say EBA, what do I know about that looking at those angles? They are the makeup of this angle and this angle, right? So I could say the measure of EBA equals the measure of angle 3 plus the measure of angle 2. Can we agree on that? Now this is where you're going to have to use your journal because you have to tell me which postulate this is talking about. What did I just do? I added two angles, right? So this is the angle, whoops, addition postulate. All right, so now look at what we have here. We have measure of angle 3 here, and you have measure of angle 3 here. Can I switch those? So then can I say, since the measure of angle 3 here equals 1, could I plug the measure of angle 1 in there? Yes. So we can say the measure of angle EBA equals, this is where we're going to substitute, the measure of angle 1 plus the measure of angle 2. So what rule do you think I used here? Substitution property, yep. Okay, now let's look at the other angle that they're trying to get us to prove. So I'm going to erase this up here. So that we talked about EBA right now. So now let's look at DBC. DBC goes this way. Well, we can go back to what we did earlier, and what did we say about these two angles? Yep. Measure of angle DBC equals the measure of angle 1 plus the measure of angle 2. And we use the same postulate, angle addition postulate. Okay, now what do you notice? What's right here and right here? They're the exact same thing. So can I substitute and plug in this angle for here? Yeah. So the last step is I can say the measure of angle EBA equals the measure of angle DBC. And that, do you remember the property that was? Remember, if one thing equals one and then that same thing equals a different thing, it's transitive.
Is it easy?
Shh. Transitive property. And if you look here, this is what we wanted to prove to begin with. Congratulations, you have just written your first proof. Okay, so moving into example 5. Put this in your journals. So we have a diagram, and in this diagram, we know that AB equals CD. We're trying to prove that AC equals BD. So, first things first, we're going to write AB equals CD, and what is the reason for that?
AB equals CD?
Yeah, what's the reason?
Given.
Very good. Almost always your very first step is the given. All right, so what could be our second step here? Without looking at your books, I know that's hard. So we're trying to show that AC is equal to BD. So we need to get to where we can do a transitive property, I'm assuming. Or something along those lines. How do we tell what the length of AC is? AB plus BC equals AC. And this is just segment addition postulate. Okay, that's just part of adding up segments. If the two segments are added together, they equal the third length, the whole length. Okay, now what about for BD? Can we do the same thing? BC plus CD equals BD. And what is the reason for this one?
Segment addition.
Yep, same thing, segment addition postulate. Now, if I have the same thing here a couple times. I'm having some issues. There we go. All right, now we know that this original up here, AB equals CD. So what if we add BC to both of those? That's this middle segment. So if we say AB plus BC, that should still equal CD plus BC, right? Because we added the same thing to both sides.
Yeah.
This is the addition property. What's the last thing we can do? We're trying to get AC equals BD.
Well,
Let's look here. So we have this little phrase is the same as this one, right? So I can put this instead and say AC. And then this little phrase is the same as this one. So I can put this one instead. Right? And what did I do? I substituted. So substitution property of equality. Okay? Any questions on that? Just take your time. Ben, we're in the middle of class. Give her 5 minutes. Any questions on this? All right, so when you're working on, you're doing exercises 3 through 31, just the odds. Okay,